Good morning. If you have ever analyzed any question paper of the competitive exams, you will find at least one question that count the number of triangles in the given figure, and also it requires a lot of time. That's why today I am Shourya Bhajbhuje from Standard 6th Bajaj Science Center Varda, showing you the trick that how to find the total number of triangles in the given figure in less than 5 seconds. So we have divided this into 6 types. So type 1. Here there are vertical divisions. So here we will use the formula, that is n into n plus 1 by 2, where n is equal to the total number of parts. So in this figure there are 2 parts. So n is equal to 2. Then n plus 1 is equal to 2 plus 1, that is 3. And the total number of triangles is equal to n into n plus 1 by 2, that is 2 into 3 by 2, that is 3 triangles. In this figure n is equal to 4. So 4 into 5 by 2, that is 10 triangles. So here there are 10 triangles. In this figure there are 6 parts. So n is equal to 6. 6 into 7 by 2, that will give us 21 triangles. Now in type 2 there are horizontal divisions. So for this we have to just count the number of number of horizontal lines, and we will get the number of triangles. Like in this figure there are 3 horizontal lines, so 3 triangles. In this figure there are 5 horizontal lines, so 5 triangles. Then in type 3 there is like kind of mixture of type 1 and type 2. Here there are vertical divisions as well as horizontal divisions. So here first in this figure there are 3 bases, base 1, base 2 and base 3. So we will use type 1 formula, that is n into n plus 1 by 2. So in this base 1 the 6 parts are there. So there are 6 into 7 by 2, that is 21 triangles. In this base 2 there are 2 parts. So 2 into 3 by 2, that means 3 triangles. In this base 3 there are 2 parts. So 2 into 3 by 2, that is 3 triangles. So in total 21 plus 3 plus 3, that is 27 triangles are there in this given figure. Then in this figure there are 3 bases. So there are 2 parts. So 2 into 3 by 2, 3. This base 2 into 3 by 2, 3. And again this base 2 into 3 by 2, that is 3. So 3 plus 3 plus 3, that is 9 total triangles. Then type 4. Here there is a square which is cutted like along its diagonal. So we will use the formula n into 2, where n is equal to the total number of parts. So in this figure there are 4 parts. So n is equal to 4. So total number of triangles is equal to 4 into 2, that is 8. In this figure n is equal to 8 because there are 8 parts. So 8 into 2 is equal to 16. There are 16 triangles. In this figure there are 2 squares divided into 8 parts. So in the square 1, the total number of triangles is equal to 8 into 2, that is 16. And in this square 2, the total number of triangles is equal to 8 into 2, that is again 16. So 16 plus 16 is equal to 32. Then if this figure is given like this, so first we will calculate the first square's total triangles, that is 4 into 2, that is 8. In second square 4 parts, so 4 into 2, that is 8. And there is one common line joining the squares. So there are total 2 endpoints. So 8 plus 2, that is the endpoints, that will give us 18 triangles. Then in this figure there are 3 squares, 4 division. So 4 into 2, 8. 4 into 2 in the second square, 8. Again 4 into 2, 8. 2 lines means 4 endpoints. So 28 triangles. Then in this type 5, there are triangles embedded inside the triangles. So here we will use the formula total number of embedded triangles into 4 plus 1. So in this figure there is one embedded triangle. So n is equal to 1. So 4 into 1, that is 4 plus 1. So there are 5 triangles. In this there are 2 triangles embedded. So n is equal to 2. So 4 into 2, that is 8 plus 1, 9. In this figure 3 embedded triangles. 4 into 3, 12 plus 1, 13 triangles. Then Now let us move on to type 6. Here there are a pattern like this. So for this we will use the formula n into n plus 2 into 2n plus 1 by 8, where n is equal to the total number of triangles along the side. So here there are 3 triangles along the side. So by using the formula we get 3 into 3 plus 2 into 2 into 3 plus 1 by 8, that is 3 into 5 into 7 by 8. That will give us 13.125, and we will consider only the integer part. So that will give us 13 triangles. There is one more way to solve this question. So there were 3 triangles along the sides. So we will write it as 1, 2 and 3. Then we will keep 1 as it is. Then we will add this 1 to this 2. That will give us 3. Then we will add this 3 to 3. That will give us 6. Then we will do the addition. So we will get 10. Then from down we will do alternatively cross and tick. So here there was a tick. So we will consider this as one more time. And then we will add this 3. So we will get a total number of 13 triangles. From the both method we get the same answer. Now let us see this question. Here there are 6 triangles along the sides. So by using this formula we get n is equal to 6. So 6 into 6 plus 2 into 2 into 6 plus 1. That will give us 6 into 8 into 13. So by 8, so we will get 78 triangles. And by using the other trick, so in this figure there were 6 triangles along the side. So write 1, 2, 3, 4, 5 and then 6. Then take 1 as it is. Add this 1 to 2 will result 3. 3 plus 3 is 6. 6 plus 4 10. 10 plus 5 15. 15 plus 6 21. Do addition. We will get the answer as 56. Then from down do cross and tick alternatively. Cross tick, cross tick, cross and tick. So take 1, 6 and 15 one more time. Plus 1 plus 6 plus 15. So that will result us 78. So there are total 78 triangles.